So on the class kick, I'll do the first one. And then how about if you guys do the next two, and then we'll go over those together. Okay. And again, hopefully you're on, but the code is in the upper right-hand corner of the screen here. So we want to find all of this information. And basically, if we find all of this stuff and put it together, we should get a fairly accurate picture of or sketch of our graph. So let's first take a look at all of the stuff we can figure out from the equation right now. I can say that this graph is discontinuous at x equals 1. And discontinuous means that like 1 is not in the domain of the function. I cannot plug 1 into this function because it would make the denominator equal to 0. So when it comes to discontinuities, there are two types. A discontinuity is either a hole or a vertical asymptote. Okay, not both. Can't be both. It's one or the other. And in this case, it is a vertical asymptote. So we have a vertical asymptote at x equals 1. So I'm actually going to make that a different color because I'm going to make my vertical asymptote a different color. So how about blue? That sounds good. So our vertical asymptote is at x equals 1. And I'm going to draw that on the graph. So here's, put a 1 there. And I'm going to draw a vertical asymptote at x equals 1. Now remember, because it's an asymptote, when you write that equation, you have to write x equals. And that kind of gets some people that they just want to say 1. We want to write it as x equals 1. Okay? Now, there are no holes, okay? And the reason there are no holes is because this x minus 1 does not cancel out. There's no x minus 1 on the top. If it did, that would create a hole. If it doesn't, it creates a vertical asymptote. All right, so we have our vertical asymptote at x equals 1. Second, we can get our horizontal asymptote. That's where we do the top heavy, bottom heavy, or equal. So you would look back at your notes if you have those from the worksheet from yesterday, but the horizontal asymptote, in this case, we're looking at the degree of the top and bottom. They're both first degree. And if they are equal, then we use the sorry, just answering a question here. If they are equal, we then use the leading coefficients, which are 2 over 1. That is our horizontal asymptote. And again, that is a line, so we want to write an equation of y equals 1. I'm sorry, not 1, y equals 2. Okay, 2 over 1, the leading coefficients. So I will go up to 2. And I will put a horizontal line. All right, now let's find any intercepts. So an x-intercept, you get an x-intercept when the output is equal to 0. So whatever makes the top equal to 0 would make the output equal to 0, because 0 divided by 0, of course, is 0. So that means that if I plug in -5/2 for x, that would make the top equal to 0. That is my x-intercept. My x-intercept, my x value is at -5/2. And of course, the output is 0. The y value is 0. So at -2.5, I have an x-intercept. To get our y-intercept, that's when x equals 0. So I'm plugging 0 in for x's. So both of those things become 0. And we're left with just 5 over -1, which is -5. So we have a y-intercept at -5. And again, I got that by plugging a 0 in for x. So I get 5 over -1. So y-intercept is at -5. So as a coordinate, our x is 0, of course. So that's at 0, -5. Now, those 2 points are really helpful in drawing this graph because I now know what the left part of the graph looks like. When I say left, I mean left of the vertical asymptotes. Remember, on the left side of the vertical asymptote, the graph could either look like this or it could look like this. Well, of course, it has to be the bottom one based on the x and y intercepts. So I'm going to draw that. There is the left part of the graph. To draw the right part of the graph, to the right of the vertical asymptote, it could either look like this or like this. I know it has to be on the top. And the reason it has to be on the top is because for it to be on the bottom, it would have to have an x-intercept. It only has the one x-intercept over here. Therefore, this cannot happen. So it can only be on the top. Okay, and another way to figure that out would be simply plug in a point over here. If I plug in, let's say 3 in for x, I could get the output and see if the output is greater than 2 or less than 2. That would be another way to find it. All right, any questions on that before I turn you guys loose to try your own?
Wait, I have a question about the second part of the graph. I thought that it would have to be down because there isn't another x-intercept.
So the only way that it could be down here would be if it crossed the x-axis again.
Oh, okay, got it. I wasn't really like looking, I guess. I just kind of.
No, I get you. So that's what you want. I mean, it's not always the same reason. So you got to kind of piece together from all your information. And it cannot do that without crossing the x-axis. Therefore, it can't be on the bottom. Good question. Anything else? So looking at the second problem from class kick, and tell me if I'm going too quickly, I would suggest finding things in this order. The first thing is to find the vertical asymptotes or holes, but in this case, nothing cancels. So to find the vertical asymptote, that's going to be whatever makes the denominator equal to 0, which is going to be x is -1/2. Now, if you have trouble doing that in your head, that's okay. You can always just figure out, all right, 2x plus 1 equals 0 and solve that. And you guys can all solve those. I mean, move the 1 over. So we get 2x is equal to -1 and x is equal to -1/2. That is your vertical asymptote. Your vertical asymptote is at x equals -1/2. So, all right, there's -1. I'll make a vertical asymptote at -1/2. So we found the vertical asymptote first. Second thing I'm going to find is the horizontal asymptote. And to find the horizontal asymptote, that's where you do the top heavy, bottom heavy, or equal. And remember, we're not doing any top heavy ones. So it's either bottom heavy or equal in this case. And that depends on the degree of the top and the bottom. So these are both x to the first power. If the top was like x to the 5th and the bottom was x to the 1st, that would be top heavy because 5 is bigger than 1, of course. If the bottom was x to the 8th and the top was x to the 1st, that would be bottom heavy because 8 is bigger than 1. But they're both to the first power, and that means they're the same. And if they're the same, the horizontal asymptote comes from the leading coefficients, 4/2. 4/2, of course, is 2. That's our horizontal asymptote at y equals 2. So our horizontal asymptote is at y equals 2. And again, that came from the leading coefficients. And I will draw that on our graph. 1, 2. There is our horizontal line. Okay, so we have some really valuable information. Just by finding the vertical asymptote and horizontal asymptote, we have some really valuable information. Because remember that rational functions look like these things. They have those arc shapes. You know, they're shaped like this or like this. They have those arc shapes. So that means that if it can't cross the asymptotes, like it can't cross this blue line and this green line, that means on the right side, it would look like this, or it might look like this. And I need to figure out which one of those it's going to be. And one bit of information that's useful are the intercepts. So to find the x-intercept, that's whatever makes the top equal to 0. So that's going to be at -1/4. But again, I could just write 4x plus 1 equals 0 and solve that, and that will be my x-intercept. So 4x plus 1 is equal to 0. I'm going to solve that, move the 1 over. So our x-intercept is at -1/4, 0. And again, that came from whatever made the top equal to 0. So I'll go to my graph. Remember the blue line, this was at -1/2. So -1/4 would be somewhere in here. All right, now put together what we know. It has to go through that red dot. It cannot cross this line. It cannot cross this line. And it looks like one of those guys. That means on the bottom right, the graph has to look like that. It doesn't cross the blue, doesn't cross the vertical asymptote, doesn't cross the horizontal asymptote, and goes through our x-intercept. You also could find the y-intercept too. And to find the y-intercept, you plug in a 0 for x. And so that actually comes out to be 1, which makes sense with our graph. We don't even really need that. And then over here on the left side of the blue line, if it's not going to cross the blue or the green, it has to look like this or like that, because those are the only ways it wouldn't cross the blue or the green. Well, I know it cannot be the bottom part. And I know that because for it to be down here, it would have to cross the x-axis again. But we only have one x-intercept. So it cannot be on the bottom. It has to be on the top. And that would be our graph. So it's like a puzzle. We're just trying to put all of these pieces together. All right, let's do number 3. I'm sorry, were there any questions on this before I move on? Okay, let's do number 3. Find the vertical asymptotes first. Vertical asymptotes are whatever make the bottom equal to 0. Well, I think I can factor that actually, and it probably looks a lot nicer if it's factored. I think that factors into x minus 3 times x plus 2. That means I have vertical asymptotes at 3 and -2. Okay, whatever makes the bottom equal to 0. Remember, so at x equals 3, I guess I made my vertical asymptotes in blue. I'll try and stay consistent here. So there is one vertical asymptote. And at x equals -2, there is our other vertical asymptotes. Now, for our horizontal asymptote, that's whether it's top heavy, bottom heavy, or equal. Well, the degree of the bottom is second degree because it's x squared. And there are no x's on top. So that actually counts as a 0 degree. Think of it as like negative 5x to the 0. So if the top is 0 degree and the bottom is second degree, that makes it bottom heavy, which means y equals 0.
Wait, I have a question.
Yes.
Is that supposed to be +1? Because I put +1, not +2.
Oh, thank you very much. I factored incorrectly. Who said that, Sadika?
Yeah.
Thank you. You are correct. I factored that incorrectly. Not going to be a big change here, guys. I'm sorry. But she's right. That factors into x minus 3 times x plus 1, which means our vertical asymptotes are at 3 and negative 1. So I'm going to cheat a little bit and just erase that. So that's now at negative 1. Thank you. All right. Let's keep going with our x-intercepts are whatever make the top equal to 0. But there are no variables up top. It never will equal 0. The top is always negative 5. Therefore, there are no x-intercepts. To find the y-intercept is when x is 0. Well, if I plug in a 0 for the x's, these things become 0. And I get negative 5 over negative 3, which is 5/3. So the y-intercept is up here somewhere, okay? Positive. All right, now that's a big deal because now I know if it's going to approach these blue lines and not cross that green line, that middle part has to look like that. It can't come down here and cross the x-axis. There aren't any x-intercepts. So it would have to look like that. Now, on the right side of the graph, it's either going to be above there or below there, because remember, it can't cross the blue line or the green line. So I don't know if it's the top part or the bottom part. Well, one way to figure that out would be to plug in a number that's over there. So remember, this was we had 1, 2, 3. So a number bigger than 3 if we plug in 4, okay? And I only need to know if it's positive or negative, really, because if it's positive, it's up here. If it's negative, it's down here. If I plug 4 into the equation, 4 plus 1 is 5, which is, of course, a positive number. 4 minus 3 is 1, which, of course, is a positive number. And if I have negative 5 divided by 2 positives multiplied together, that's going to be negative. A negative divided by a positive would be a negative. And that means the bottom part is the graph and the top is not. Now over here, on the left side, our graph is either going to be on top or on the bottom. Okay, again, those are my only choices because it can't cross the blue or the green. So I'll plug in a number somewhere over here and see if it's positive or negative. You know, remember that was at negative 1. So if I plug negative 2 into my x's, so I plug negative 2 into my x's, negative 2 minus 3 is a negative, because that's negative 5. Negative 2 plus 1 is a negative, because that's negative 1. A negative times a negative means the bottom would be positive. And if you took negative 5 divided by a positive, you would ultimately get a negative, meaning the bottom would have to be your graph and not the top. So that is the sketch of our rational function.
If there was another equation like this, wouldn't you know by only doing one line what the other line would be?
When you say one line, are you talking about like this?
Yeah.
That the other one would be here?
Mm-hmm.
It actually depends on the degree of the top and bottom. So if you have an even degree there, they do end up in the same direction. If it's not, we could have situations where they're in opposite directions. So that rule kind of sometimes works, but you got to be real familiar with the degrees and how they go. So good question. You're making connections there, though. Anything else? All right, let me go to our worksheet from yesterday. And I'm going to just do two questions, 13 and 14, just to give you a little bit extra notes. And I am taping or filming this, by the way, and I'll post this video in case you want to go back and look at it. So let's take a look at problem number 14. And I'm going to graph that. When you're graphing it, first thing is, let's try and find the vertical asymptote. Not so bad in this case. It's whatever makes the bottom equal to 0 and it doesn't cancel. So I have a vertical asymptote at x equals 2. So there is my vertical asymptote. Second thing, find our horizontal asymptotes. All right, well, for a horizontal asymptote, I have to figure out if it's top heavy, bottom heavy, or equal. Well, this one is bottom heavy because the bottom is x to the first and the top, remember, is x to the 0. So that's bottom heavy. And if it's bottom heavy, then that means your horizontal asymptote is always at y equals 0. Now my x-intercepts, that's whatever makes the top equal to 0, but that cannot happen, so there are no x-intercepts. To find my y-intercepts, I plug in a 0 for x, and I get -3/2. So my y-intercept is at -1.5. All right, that's good news. And that's good news because for it to go through this point, not cross this line, and not cross this line, but approach them in that way that rational functions do, graph would have to look like that. Now, on the right side, it's either up here or down here. So one way we could figure that out, plug in a number. Just see if it's positive, it'll be up here. If it's negative, it'll be down here. So let's plug in the number 4. If we plug 4 into here, well, 4 minus 2 is 2, which of course is a positive number. And if you take 3, divide it by a positive number, you get a positive number, meaning it would have to be on top and not on the bottom. And so getting back to the previous question we had, again, looking at degrees, because this is a first degree, these guys are in opposite quadrants here, so to speak. All right, so that's it for number 14. Now 13, that's uglier, but I'm going to try and factor it to see if I can make it look a little nicer. So when I factor the top, let's see, I'll factor a 2 out of there. I get 2 times x squared plus 5x plus 6, which factors into 2 times x plus 6. Whoops, that's not right. Sorry, x plus 3 times x plus 2. I'm having trouble factoring today. And on the bottom, that factors into x plus 2 times x minus 1. Wait a minute, that's not right. x plus 2 times x plus 1. All right, now notice what happened. This is the bottom factored. This is the top factored. And look what happens to our x plus 2's. They cancel out. And so we can clean that up. The function is now this, 2 over x plus 3 divided by x plus 1. So I'm just going to graph this. Now, don't forget about that x plus 2. I'll bring that together at the end because that's actually going to make a whole, and I'll show you exactly what that looks like. But before I do that, just graph this like we've been doing the last few problems. First, graph the vertical asymptote. Vertical asymptote will be whatever makes the bottom equal to 0 at x is -1. There is our vertical asymptotes. The horizontal asymptotes, we do the top heavy, bottom heavy or equal. These two are equal because they're both x to the first. Now don't forget on the top, that's 2 is our leading coefficient. So it's 2 over 1, meaning we have a horizontal asymptote at y equals 2. All right, we're getting there. X-intercept is whatever makes the top equal to 0. Well, that would be at -3. Because -3, would make the top equal to 0. All right, that's good news. That gives us a huge, valuable chunk of information. Because for it to go through this point, not cross this line, and not cross this line, the function must look like that on the left. Now, on the right side, the function may be up here, or it may be down here. Remember, I only have one x-intercept. It can't be down here because it would have to go through the x-axis. Therefore, it can't be there. It has to be here. And you could, of course, find the y-intercept, plug in a 0 for x, and you get 6, 12 over 2, which makes sense. But we don't even need that information. That is our graph. Almost. Because don't forget our purple friend here that we canceled out. Because the x plus 2's cancel out, that means the graph has a hole where x is -2. So we look where x is -2, and we go down to the graph, and it has a little hole there where x is -2. So I'm actually going to redraw that. It is going to approach that green, come down through our x-intercept, but then it has a hole there where x is at -2 and continues to go down. So that would be the graph of our function. Now to find the exact y value of that hole, we know that x is -2. What we could do is take -2 and plug it into the remaining stuff for x. So if I did, and I'm plugging in -2 in for x, so 2 times -2 plus 3 would be 1 over -2 plus 1, which is -1. It would be at -2. So I guess in my picture, this blue hole should be a little higher here. Should be at -2 -2. And the reason I'm pointing that out is because when you do some delta math, it may ask you for that specific point, and we want to find that y value by plugging it in here. So let me draw that one more time for you guys here. Don't want to lose my x-intercept. Got my hole at -2, -2. Got our graph that looks like this. And, you know, this is a tedious process to try and get all those pieces in, but we're trying to piece that puzzle together for our entire rational function. All right, any questions, guys?